There it is right there. We're looking right at our books, finding the surface area of a cone. And what they say here is what we were just doing. It's still going to be L plus B, much like it was when we were doing the prisms and cylinders and pyramids. But to find the cone, it's pi times r times the slant height plus pi times r squared. So we're still getting our L and our B there, but just like the other shapes, it has its own unique way of getting the L and the B. Let's go and take down this question here. I'm going to write that too, before I forget. S equals L plus B. So a company packages popcorn in paper containers in the shape of a right cone. Each container also has a plastic circular lid. Find the amount of paper needed to make each container. Then find the total amount of paper and plastic needed for the container, round to the nearest tenth. So they want me doing two things here. Paper needed to make each container, and then the total amount needed, paper and plastic for the container. Okay. So really they want the lateral area, and then they want the lateral area and the base area. So let's start with the lateral area for this one. Remember, the lateral area is pi times r times the slant height, L. They don't give that to us here. We're going to have to use the Pythagorean theorem to figure that out. So let's go find the slant height. Shouldn't be too difficult. We're going to have 6, 8, 6 and 8, and this is a Pythagorean triple, but we'll go through it anyway so we can see for sure. We got 6 squared plus 8 squared. That's going to equal the slant height squared. And we got 36 plus 64, still equaling the slant height squared. That's going to be 100 equals slant squared. That's going to be 10 equals the slant height. Okay, so we know the slant height is 10 now, so now we can fill this out. We know the radius, pi times the radius, which is 6, times the slant height, which is 10, and that's going to be 60 times pi. Now that's how much paper we're going to need. Oh, come on, I hit the other thing. That's how much paper we're going to need here for each container, but now we've got to get the base height and then add it to that so we can get the paper and the plastic. So the base height, that is as easy as finding the area of a circle. That's pi times r squared. We know what the radius is. It's 6, so it's pi times 6 squared, which is going to be 36 times pi. Now I can add that. There's no part of the question needs just the base area. Well, it's kind of weird because we're talking about two different parts altogether. So for the second part of it, it does seem like they want us to add the paper and plastic. So two different materials, but we'll do it anyway. So the S, now that we know the L is 60 pi, and the base is 36 pi, this should be pretty darn easy. 60 plus 30 is 36 is 96 pi. And they want everything to the nearest tenth. So let's get this, and then we'll go back and do this because that's just the paper. So we'll do 96 pi first. That's going to be 301.6. Oops. It's going to be 301.6 square centimeters. So that's how much paper and plastic will be needed, and the amount of paper we'll do by doing 60 times pi. $188. Let's go with 0.5. Okay, I'm going to try to write this in my best penmanship here. I'm going to write this in my best penmanship. This is total, and this is just for the paper. So if you're looking for the steps to finding the area of a cone, there's 3 of them right there. Remember the lateral area was pi times r times L, and the surface area is pi times r squared, and then you just put them together when you're done. And if they ask for you to do it in something other than pi in terms of pi, then you should round to the nearest 10th or 100th or whatever they tell you. So that would be step 4, if necessary. Now let's get back to the fun stuff, actually solving problems. We're going to find the total surface area of this cone. So we are still going to be doing surface area equals lateral area times the base area. Alright, so this time they've actually given us the slant height, so we're going to be in pretty good shape there. So we do have problems with the radius, though. We don't know what that is. So even though we got the slant height this time, the radius is not known, so we're going to have to know the radius. That's kind of a big part of this whole deal. So the height is 24, but the slant height is 25, and the radius we can do the Pythagorean theorem for. So r squared plus 24 squared equals 25 squared. So I don't know what r squared is, but I do know that 24 squared is 576, and 25 squared is 625. Let's subtract these two. 6, I think that's 49, right? Yeah, it's 49. R squared equals 49, and we got ourselves a nice whole number. So the radius is 7. Remember, the lateral area is pi times radius times slant height. So we can plug this in. We've got pi times the radius of 7 times 25. 25 times 7 is 175 times pi. Now let's get the base. The base of a circle is very easy. Remember, that's pi times the radius squared. We know the radius is 7, so it's pi times 7 squared. And then we're left with 49 times pi. So now remember, it's L plus B. S equals L plus B. Our L is 175 pi. Our b is 49 pi. And we just have to add those together, and we're going to get 224 times pi. And let's figure out what that would be. 224 times pi, 703, let's go with 0.7. Around 703.7 square centimeters. Here is a dope U-turn. Your turn? I've been saying U-turn a lot lately. So go after these, and then when you're done, I'll have the answers right here. The neatest work I can do. So there's number 7. It was asking for the paper and the plastic. The first thing you needed to do here was find the radius, which I did using Pythagorean theorem, and just went through the formulas there that we've developed for the lateral and the base areas. Got 15 pi and 9 pi respectively, and ended up with 75.4 square inches for the total. And then I had to go back and just convert the 15 pi, which is just the lateral area, and convert that to decimal value. Got 47.1. This one you had to go through a similar exercise because you had no radius. They didn't give it to you. And when you did the Pythagorean theorem, you should get a radius of 1.5, and then it was all downhill from there. We had the 3.75 times pi for the lateral area. Also ended up being about 11.8 inches, and I just noticed I put the decimal value there. It was 11.8 square inches. Okay, fix that one. Of paper and papers needed, and 18.8 square inches of paper and plastic were needed. The base was relatively easy to find because all you had to do was square 1.5 and then multiply it by pi.